Okay, so in this section we cover the last conic section called the parabola. So a parabola is the set of all points in a plane equidistant from a fixed line called the directrix and a fixed point not on the line called the focus. So we begin with a fixed line and a fixed point, then sketch all the ordered pairs equidistant from one and the other. This graph's the familiar parabolic shape discussed in like intermediate algebra, like chapter 1, chapter 2 of this class. So in this figure, the vertex is the midpoint of the focus and the directrix. And the line through the vertex and perpendicular to the directrix is called the axis of symmetry, just because it cuts this line, it cuts the parabola in half. So we say like the distance from the vertex to the focus is p, and then the distance from the vertex to the directrix is negative p. So p is what we call a directed distance. It's positive in one direction and negative in the other, depending on which direction we're traveling. Like if we're going up from vertex to focus, then p is positive. If we're going down from vertex to focus, then p is negative. But if we were to say, let's just put the vertex at 0, 0 because it's convenient, then the focus is at 0p, whether you're going up or whether you're going down. And we were to say, well, what is the set of all points that's equidistant to the focus and the directrix? This line is called the directrix. It turns out we would get the equation x squared equals 4py, assuming, I was saying this line is the directrix. I didn't have my picture up there far enough. So this line is the directrix. So we're saying what is the set of points that's equidistant to the focus and the directrix? We would get this equation, assuming the vertex is put at 0, 0. So if we're opening upward, we have a positive p. If we're opening downward, we have a negative p. Okay. Now, it is possible that a parabola opens left and right as well. Like maybe we've created a focus and a vertical directrix. So if we were to say, let's put the vertex that's halfway between the focus and directrix at 0, 0 just for convenience, then the set of points that's equidistant to the focus and directrix would satisfy this equation, y squared equals 4px. Again, p is the distance from vertex to focus. We open rightward if p is positive and open leftward if p is negative. So the idea here is that if we see x squared, the parabola is going to open up or down. If we see y squared, the parabola is going to open left or right. Okay, so like in the first example, we find the focus, the vertex, and the directrix of this parabola, y equals negative 1/12 x squared. So what we're going to do here is we're going to put it in the form x squared equals 4py. I mean, we have two choices. Either x squared is 4py or y squared is 4px. Well, I've got x squared in this equation, so it's got to be this one. And so we're isolating x squared. This is easy enough to do. Let's just multiply both sides by negative 12. That would give me negative 12y equals 1x squared. Or I could just say x squared equals negative 12y. So the vertex here is 0, 0. I mean, when we just see a plane x squared and a plane y, the vertex is going to be 0, 0. We'll look at shifted parabolas in a little bit. So next we find like the focus and all that stuff. So the idea here is that the negative 12 on the right side is 4p. So if 4p is negative 12, then p is negative 3. Now, because we see x squared, this parabola opens up or down. Since p is negative, it opens down. The negative 3 tells us we go down 3 from vertex to focus. Well, if I start at 0, 0 and go down by 3, I must have a focus of 0, negative 3. To get the directrix, I think it's usually easier to just sketch the graph. So let's do this. So I have a vertex of 0, 0, and a focus of 0, -3. Now, the way we get more points on the graph is pretty easy. We don't have to plug points in. What we do is we get level with the focus. Now, 4p was -12, so I'm going to focus on the number 12. The idea is if I go left by 6 from the focus and right by 6, I'll create an axis that's a total length of 12. Again, getting 12 from this. So what I'm going to do is exactly that. I'll get level with the focus, and I'll go right by half of 12. I'll get level with the focus, and I'll go left by half of 12. This gives me a total axis length of 12, and these points are on the parabola. Not that we have to do this, but I'm going to point out, so this is 12 units, and I'm getting the 12 from 4p. Even though 4p was -12, I'm focusing on the 12. So the last thing is the directrix. The defining parts of a parabola are its focus and directrix. So we know the focus. If all the points in the parabola are to be equidistant from the focus and directrix, well, the vertex is 3 units from the focus, and so the vertex must be 3 units away from the directrix as well. We have two choices: either the directrix is horizontal or vertical, but the idea is that the parabola, and we can see this up here, opens away from the directrix. So I think the directrix has to be horizontal, lest we run into the parabola. I mean, if it were vertical, it would hit the parabola. The equation of this directrix, well, we're up 3 units, so it would be y = 3. And so that's our directrix. In the next example, now we don't know the equation, but we're given the vertex and focus. Really, given the vertex and focus, I can graph the parabola pretty quickly. I should warn you, there should be a fairly long y-axis. I'll probably need the whole rest of the paper here. So I have a vertex at 0, 0, and a focus at 5, 0. So this tells me that, well, I'm going right by 5, so p is going to be 5. Okay. If p is 5, then 4p is 20. So I need to go, I bet I haven't even given myself enough room here. So get level with the focus, I need to go up and down by 10 to get a total axis length of 20. So I'll get level with the focus and go up 10 and down 10. And now I can sketch my parabola. So again, that's a total length of 20 units on that axis. Okay. Well, if the distance between the focus and the vertex is 5, then so is the distance between the directrix and the vertex. So I'll go left by 5 to get to the directrix, which is then x = -5. This line has to be vertical. If it were horizontal, it would run into the parabola. The parabola is supposed to open away from the directrix. So again, this thing is the directrix. The equation's pretty easy. So let's think about this. Because this thing opens horizontally, okay, well, let's remember left to right parabolas have y squared in them. So it has to have this form, y squared equals 4px. The vertex is at 0, 0, so I should expect a plane x and a plane y squared. Well, I said explicitly what 4p is, so y squared is 20x. Going on to the last page. So we don't have to have vertices at 0, 0. We can have them anywhere. So in the next couple examples, we look at where the vertex is not 0, 0. And not only that, but the equation itself is unorganized. So we're going to organize it and come up with all the features of the graph. In this one, we have x squared plus 6x plus 4y plus 5 equals 0. We notice that unlike with the ellipse and hyperbola, it is not the case that both variables are squared. That's not what happens in a parabola. But spiritually, we do the same thing. We need to complete the square. Completing the square doesn't make any sense for y because there's no y squared. So I must be completing the square with x. Immediately then, what I'm going to do is I'm going to move anything that's not involving x's over to the right side. 6 is 3 and 3. So if I multiply 3 and 3, I'll have that third number. So I'll add 9 to both sides. X squared plus 6x plus 9 is formed by 3's. So this is x plus 3 squared. On the right side, negative 5 and 9 is 4. So I'm looking at negative 4y plus 4. Now I can look at this and say that the x coordinate of the vertex is negative 3. But I cannot look at this and say what the y coordinate of the vertex is, at least not just directly by looks. What I have to do to make that decision is make it myself have a 1y. So I'm going to factor out the number in front of y, no matter how messy that makes the right side. Now, in this case, it's nice that the 4's have this 4 in common. So if I factor negative 4 from both of those, I'm left with y minus 1. And so immediately now I can say that the vertex is negative 3, 1, the opposites of the numbers next to x and y. And I need this. I need something. I need some point on the parabola to be able to graph it. So I need to define the vertex first. Focus is pretty easy though. So now that we've got this in the right format, we can say 4p is the number on the right side, so negative 4. And this tells me then that p is negative 1. Now let's look at the features here. It's got x squared, so that means it opens up or down. P is negative, so it must be down. So we're going down 1 from vertex to focus. What this tells me then is that the focus is at negative 3, 0. Again, if I begin at negative 3, 1 and then I go down by 1, that puts me at negative 3, 0. Again, I think that the directrix is more easily found once we graph it. So let's go ahead and do that. So I have a vertex at negative 3, 1. I have a focus at negative 3, 0. And let's remember, how does this help us? So the focus helps us get more points on the parabola, because I can say, if I go, so 4p was negative 4, so I'm going to focus on the 4. So if I go get level with the focus and go left and right by 2 units, then I'll have a total length of 4 going across the axis that contains the focus. This gives me points on the parabola. So I have a parabola looking like this. So again, I made a 4 unit axis here going across the focus or going through the focus, and that 4 came from the 4p. Since 4p was negative 4, I focused on the 4 part of that. The focus is the midpoint of that axis. Now, for the directrix, I'm supposed to open away from the directrix. So I must be drawing a horizontal line. And I'm drawing it 1 unit above the vertex because the focus is 1 unit below the vertex. So it's a horizontal line passing through y equals 2. So the equation of the directrix is y equals 2. And I believe we found everything now. For the last example, it's the same sort of thing. Notice that y is squared instead of x. So anything not involving y should be moved to the right-hand side. Negative 2 is created with negative 1 and negative 1. And this means that the third number must be 1, because that's negative 1 times negative 1. And of course, if I'm going to add 1 to the left side, I had better add it to the right side. Then the left side factors as y minus 1 squared. The right side is 8x plus 32. In order to find the x coordinate of the vertex, I'm going to have to take out the number in front of x so that I see a 1x. This tells me then that the vertex is negative 4, 1. Don't be fooled by the left to right order of the equation. An ordered pair is always listed x then y. So the number next to x and the number next to y. Now that we have this in the right format, we can say that 4p is 8. If 4p is 8, then p is 2. So let's see, let's look at the features here. What does p tell us? So we have a y squared. That means the parabola opens horizontally. Since p is positive, we go in the positive horizontal direction, which is right. So p equals 2 tells us we go right 2 units, from vertex to focus. Well, if I begin at negative 4, 1 for the vertex and travel right by 2, then I must be at negative 2, 1. As usual, let's find the directrix after we get a graph. So we begin at negative 4, 1 for our vertex. We're at our vertex. The focus is negative 2, 1. And again, we create an axis here that runs through the focus and is 4p units long, or at least the absolute value of that number. 4p is 8. So when I get level with the focus, I'll go up by 4 and down by 4 for a total of 8 units. And now I can sketch this thing. So just to note that, that's 8 units. And that 8 came from 4p. Make that p a little better here. Oh, now it looks worse. For the directrix, it better be vertical so that the parabola can open away from it. And since p is 2, we must go left by 2 to sketch it. Well, it looks like I'm at x equals negative 6 here. And so my directrix is x equals negative 6. And thus concludes 9.3.